right. Hello, everyone. So maybe a little bit about me first. My name is Brian Ford. I have been at Uber for about a year. I work on the DataViz team. We actually have a separate series of just DataViz meetups. So if you're curious about that aspect of my work, you should come check it out there. But I'm super interested in like developer tools and like how can we do a better job writing applications. How can we make them faster? How can we make them more robust? How can I improve my own developer experience? These sort of things. So I was really interested when I heard about Elm. So Elm, if you haven't heard of it, maybe you looked it up because you came to a meetup where someone was presenting about Elm. But it's like a pure functional language for creating web apps. And it's really robust and it's really friendly. And hopefully you'll understand what I mean by friendly in a bit. It compiles to JavaScript. And kind of one of the crazy things is if it compiles, it's impossible to have runtime exceptions. Like, it doesn't have runtime exceptions at all. So like, how is that even possible? We'll get into that. But like, just think of how much time you'd save if you didn't have to debug crashes, right? Like, that's amazing. So like there's lots of things that cause runtime exceptions, right? So this is JavaScript. We have this thing undefined in JavaScript, and sometimes you can't read property name of undefined. Sometimes you try and call a function and it's undefined is not a function. That's one of our favorites, right? There are other things though too, right? Like control flow. So here we have kind of this silly function called doMath. It handles adding and subtracting. But if we pass in an option for doing multiplication, we get undefined, and then later on in our program we use it, and then we see nan all over the place. It's just not fun. So there's only like two ways that I thought of to eliminate runtime exceptions. One of them is just to write perfect code with no bugs, right? Like many of you do, I'm sure. And the other way is to kind of automatically enforce it. And so the cool thing about Elm is it kind of goes the second route. It's kind of a tough sell though, right? Like Elm is an entirely different language compared to JavaScript, and we'll see what the differences are in a bit. But why a new language? Why not use some tool on top of JavaScript, right? We have things like ESLint that help out with correctness. There's Flow and TypeScript. We'll hear about Flow next. I'm not trying to steal the thunder there. But JavaScript has a bunch of features that retroactively, like you can't just add types on top of everything and fix everything. I'll show some examples of this later, but you have to add a bunch of annotations over your code, so you kind of pay a high cost to use these sort of tools. Whereas in Elm, you get this for free. Like you can't opt out of this sort of safety, even if you don't write type annotations on things. And Elm solves problems in kind of a cohesive way. To get all of the same value that Elm gives you, you need to use all of these tools. You need Babel and Flow, you use React, Redux, Immutable, and the glue between these gets complicated. If you've ever started a new web app, there's just so many options. Like it's really, quite overwhelming. And there's a bunch of kind of cross-cutting concerns that fall between the cracks in these different tool boundaries. So like, how often have you seen an error message and you're not really sure what the real cause is because you have so many layers of tools, right? Like, is this because Webpack is wrong? Is this because, my Babel transform is wrong? Like, it's sometimes a little bit hard to tell. So like, let's like learn Elm. We're not gonna learn all of it, but if you wanna play along, I think it's a much better way to learn like typing things into a REPL. You can also go to elmling.org and like download the whole runtime. And this also gives you an excuse if I'm boring to like take out your laptop and like play Minecraft or whatever. And you have like this plausible deniability that you're like learning Elm. So you have my permission. Take out your laptop if you want to. This will be a little bit more productive, I think. All right, cool. Let's jump into it. I'm not seeing a lot of laptops. You guys are really trusting me that I'm not just lying to you up here. Okay, cool. So numbers. They're pretty much the same as in JavaScript. There's a JavaScript REPL that's like writing Chrome on the left, and there's Elm on the right. One kind of interesting thing in Elm is that if you're using this REPL, you get the value, but then you get a colon, and this is the type that Elm has figured it out to be. So Elm has a separate float type. That's kind of interesting, but it has infinity like JavaScript. It has addition and subtraction. So there you go. You already know Elm basically, if all you're doing is a calculator. Okay, strings. So this is all a screenshot from the Elm REPL. I'm not going to do side by side because I trust that you guys know JavaScript. So strings in Elm you're only allowed to use double quotes. So if we type something with single quotes in here, you get this message, which tells you that Elm uses double quotes for strings. So this is pretty nice. This is a compiler error, and it even goes right into the docs if you're like super confused, which definitely happens when you're learning new things. So if you type in hello, you get a string. Okay, let's try and concatenate two strings. We messed that up too. So if we read through all of this, we see at the end here that there's a hint, and it says, to append strings in Elm, you need to use ++, not plus. So if we do that, we get hello friends. So like this is the sort of thing that I mean when I say Elm is friendly, right? Like the compiler isn't spitting out these things that like it's impossible to figure out what it means, right? I think a lot of developers have been kind of like they've spent time in C++ or something, and they're just traumatized by things that compilers have said to them. So Elm isn't like this. Like it'll tell you what's wrong. A lot of times it'll actually even suggest what the fix is to you, right in the bottom there. So I think that's really awesome. Okay, let's talk about records. So records are basically the same thing as objects in JavaScript. Records are immutable by default. So if you used immutable.js, it's basically the same concept there, right? You can't change anything inside of a record once you've constructed. So here we make, you guys actually see a cursor? Does this help? Sorry, I tried to get colorized console output, but did not quite make it in time. So here we create a record that has two fields, first name, last name. They're both strings. It happens to be my name. And if we want to get it back out, we can just do person.firstname. It's exactly the same as JavaScript. And if we try and make an assignment here, it tells us that you're not allowed to do that. You're only allowed to define variables. And it points you to the docs again if you're confused. All right. So if you do want to update something, there's a special syntax for it. This says, let's create a new variable called Bryant. And Bryant is a new record where we take the record called person and we update the first name in Bryant, or the first name to be Bryant. And then there you see it's returned back out. So one interesting thing to note is that, again, we're getting a type here, right? So it's a record that has last name string and first name also string. All right, do you guys know what implicit return is? Can I just like skip this slide mostly? So in JavaScript, there's like a million different ways to define a function. It's even worse now that we have like async functions and await and generators and all of this. The important thing is that if you're using this arrow function and you leave off the little curly braces, you get an implicit return. So implicit return is kind of a thing that Elm does like to the max. Like in any place where you could kind of implicitly return something, Elm does. And I think that this is one of the things that's a little bit confusing about it. So let's do functions in Elm. So functions are a little bit weird. You do the function name, and then you just have space delimited parameters for the function. And then you have an equal sign, and then you have the body of the function. So here we have a function called add. Interestingly, here in the bottom, it shows you this number dash number dash number. If you've worked in like a functional language before, this is normal to you. But otherwise, this is just a fancy way of saying the first two things are params, and this thing that comes out is the return value. So one other cool thing about it is it automatically curries all of your functions. Partial application currying. Sometimes you see it in JavaScript functional libraries. This is baked right into the language. So we can do something like add one, and we get a function that takes a number and returns a number. And we can even make an assignment. We can say our new function add one, and we'll call it with add and the number literal one. Wow, this is really hard to say. It's kind of a tongue twister. And then we can call add one later with the number 2 and get 3 out of it. Okay. Let's see. So this is what I mean by if else's, or rather everything kind of implicitly returns. So in JavaScript, you have like the ternary, which is kind of a shorthand way to do if else. In Elm, that's how if then else automatically works. So here we're writing a function called greater than 5 that returns either a string that's greater or lesser. It takes the single argument, and the body of the function is just if num greater than 5, then it's greater, else it's lesser. So the crazy thing here is that this guy implicitly returns, and so does this, and so does this. Right? So this is maybe a little bit mind-bending, but I promise, like, you get used to it. And there's actually some interesting things about this syntax when you get into more advanced cases. All right, unions and case. So this is like the last major thing that I'm going to talk about, and then we're going to see like an actual application. Unions are, you can think of it as just like a really fancy enum. One cool thing about a union type, it's technically a type, is that it can kind of have values inside of it. So maybe, you know, to go back to this kind of silly calculator example, we could say operation, there are two types of operations. There's either adding or subtracting, and both of them have an integer kind of inside of them, right? And then we have this case statement. So again, this sort of implicitly returns, right? So, you know, these statements that we see at the end here, whatever the value of that is, that's going to be the return value of the function. So we say case operation of, and this is kind of pattern matching, right? This is another kind of crazy feature. If it's add, we're going to destructure the addend out of it. We're going to take the integer that's kind of inside of that add, and we're going to pull it out. And we're going to add it to num, which is another one of our function parameters. Otherwise, if it's subtract, we're going to do the same thing. We're going to pull that integer out. So you can think of it this just as the same way as if you destructure an object, for instance, in a JavaScript arrow function, right? It's pretty much the same thing. Does this make sense? Yeah, maybe? Really quiet crowd. Okay, I actually lied. There's one more thing. This is Hello World in Elm. So in Elm, there's a library called HTML. This is basically just you know, very typical React-like VDOM thing. But instead of writing something like JSX, you just write function calls. So in this one, we say we're going to call text, which is a function that happens to return something that we can render to HTML, and we're going to call it with Hello World, and that creates a node. All right, so now that we're experts at this, let's build an app. So Elm has an architecture baked into it that's very similar to Redux. It's called the Elm Architecture. There are a couple of differences, but you can kind of think of things as a one-to-one mapping for simple cases. So you have a model, an update, and a view. So model, you can think of this kind of as your state. Update, this is kind of like a reducer, and view, this is kind of like React components, right? You could pretty much replace all of these boxes with like Redux words, and it would be just as valid. All right, so let's look at a simple app here. This laptop thing was going to be really cool. I was going to have everyone like pull it up and check this out, but it's not a laptop crowd. So anyway, we're going to look at a to-do list application because that's the only way you're allowed to introduce new material is if you have a to-do list application. So let's just like think about this a little bit. There's just a couple of different kind of actions here, right? So if we were doing this in Redux, which I assume many of you are familiar with, how many here have used Redux before? How many are like kind of familiar with it? Like if I say reducer, you don't get freaked out. Yeah, okay, cool, awesome. Yeah, so we would think about it in terms of like there's a couple different actions, and we would have, you know, a reducer that handles these actions, and there's a couple of different things on our state, and we can apply pretty much the same thinking to Elm. So I have a to-do list app here. For some reason, legal wanted me to include this copy right here, so I did. Get this away from here. All right. So this is what this app looks like. At the top, there are some imports. Like, don't worry about it. You can probably sort of guess what those do. You know, exposing is like, you know, qualified import, as is like an alias. So we have this main program, and in it we pass three things. We pass a model, a view, and an update. And we're going to define those below. So a model, this is the full state of our application. We want a list of entries. So these are going to be the items on our to list. And we're going to want a field. And this is the thing, this is like our text box that we're typing into, and a UID. So some kind of ID that we can use to look things up later. And maybe we want to write a helper to help us make these records, right? So make new entry, again, takes a description and an ID, and it makes a record where it's, it's a to-do list item that's not completed, it's not being edited, it has the given ID and the given description. All right, so this is where we're gonna apply that that like crazy union type thing. So I'm going to show you kind of the update function next, but one of the components of the update function is you have messages. Messages are very similar to actions. So we have one that's updating a given field, so changing the value of a to-do list item. This uses content area editable, so we actually have an action for like enabling that text box. We have an action for adding a new one and deleting, and for like actually checking it there. Okay, so this is the update function. So again, this shouldn't be too surprising. Like maybe this looks intimidating. Like probably people would have left the room if I showed this to you at first. But this just combines together all of the different like syntax elements that we talked about. So what does this do? This takes a message and a model. If message is add, then we're going to return a new model. Inside of this new model, we want to increment this UID, right? So the new UID is the old one, model, +1. Like this should start to feel very, very familiar to people using, reducers and redux, right? We want to clear out the field, right? So we inserted one, we want to clear out the old one. And then we want to update the list of entries. So here we do something, we do a little check to make sure that we're not inserting an empty item into the list. So if the field is empty, you have to use this string is empty. You can't just do equals equals empty quotes. It's a little bit, the language is a little bit more strict on that. Then we're going to return, or not even really return, right? We're just going to assign entries to the old version, right? Otherwise, we're gonna assign it to the old version, and we're gonna concat onto it this new one using this make new entry function, and passing in the current field and the current UUID. So like that's not too intimidating, right? Like those are all things that looked kind of similar. Here's maybe another example. This one's a little bit contrived, but this is how maybe we would update the description of a given task, right? So we would say, let's pull the ID out and let's pull the task out. This is again just inside of the update function. This is just one of the other cases in that switch case. And so we're using this let in syntax. So like I was saying, there's everything kind of acts as a return. So let in is kind of interesting. It binds update entry, which is going to be a function, into the scope of this statement below here. So again, kind of weird, but if we think about it, it's not really that much different from the other kind of control flow things, right? Everything in the language kind of acts like that ternary in JavaScript, or it acts like that implicit return. And once you get past that, and once you read a little bit of code like this, you start to see like, oh, there's a peak here, so I know that this is going to be one of the return things, and your brain gets used to it. So anyway. With this, basically we check if a given entry is equal to the ID that we pulled out of that action. And if it is, we update the task. Otherwise, we just return the original one. And then in our model, we go over all of the entries and we just do a map. This is the same thing as a ray.map. And we call this update entry function on each of the entries in our model. So it seems maybe a little bit roundabout compared to JavaScript, or compared to like a really procedural style, but there are a lot of advantages. All right, so the original claim that I made is that this won't ever crash at runtime. So how do I know that? I have to make good on that. So one reason is that we won't even compile if you have like a record that you try and access a field that doesn't exist, right? Again, we didn't have to add any annotations. It's just the act of making a record also kind of behind the scenes creates a type for it. So again, this is kind of cool. It'll even tell you that you know, you're trying to do something on a record that has first name, and this one only has first name and last name. Similarly, you can't accidentally like update the wrong field on a record. Kind of once a record is set in place, you know, that's it. You have to make a totally new type of record. So you have to do, you know, you have to do opening and closing braces, and then, you know, field equals whatever, new field equals whatever, and then destructure the items out of the old one. So it's, you know, it's really explicit. Like you can't accidentally mess this up. Like they removed all of the possible mistakes that you could make. All right, so the other kind of thing is exhaustiveness, and I suspect that this will come up in the flow talk a little bit too. So again, we have this like really silly do math function. If we try and call it with something that's not add or subtract, we're going to throw an error. Let's do the same thing in Elm here, right? So if we create type operation, again, we're going to use this union type thing. You know, we get a function, that's fine. Here, this is a little bit cut off. Hopefully you can see all the important bits. If we try and add mult to this operation type and we don't handle it in case, like the program won't compile. Like you can't even run that. And it'll even tell you, you need to account for the following values. REPL is just the global namespace, and then mult is this thing that we added here, right? So kind of as a bonus round, let's try and do this in flow. So in flow, you use this colon inside of here to add a type annotation. But unfortunately, this won't get caught. And the reason is, like, flow doesn't know that because you used if and else, you want exhaustiveness over operation. Like, it doesn't know that, and it can't know that. There are some valid cases where, you know, maybe we have a reduced mode of do math on more restricted hardware, and we don't want to allow multiplication because that's going to fire up too many transistors. But I think if you wrote your code like this, I think Flow would probably get it. But you'd have to assert that you want a number coming out of it, and that you want to use a switch case statement here. I think if you have an else fall through, you'll get not quite the right behavior that you intend. I think that this is right. Interestingly, in Elm, you couldn't do if else, right? Like the only way to get something out of a union type is to use case. So that's how you know that it's always going to get caught. Okay, so things that you might be wondering about. This guy's talking about this crazy thing that can never crash, but I have to, like, you know, sell my soul and stop using JavaScript. That's not really the case. You can actually use Elm alongside JavaScript. But there's kind of, there's this feature called ports, and it kind of sits in between JavaScript and Elm, and there's certain contracts that you have to fulfill so that way Elm doesn't crash, basically. So if you pass something bad back in from the JavaScript to Elm boundary, you can actually get crashes there. So I guess I did lie a little bit, but, you know. And I showed like a really like silly example here, but the Elm architecture actually goes a couple of steps further. You actually write all of your components as just those three functions: that update function, the view, and the initial state. And then, you know, you can have messages that come in and out of them, and the whole system knows if you have a message type that isn't handled, right? It's all just that case switch case thing. If you can imagine, you can actually nest switch cases as well. So, so in conclusion, hopefully you come away thinking that Elm is easy to learn. I blew through this super fast, and we actually saw and maybe even understood some of a to-do application. And it's not really that different from React and Redux. It's kind of a refinement, I would say, on top of this. So it's just React Redux +1. Even if you never use Elm, I think that the act of learning it will make you a better programmer. When you get into some of the more advanced features that I didn't show, you know, you'll think a little bit more clearly, I think, about the types in your program, right? So you'll think about how to model data up front. The syntax is very similar to other very intimidating languages like Haskell or OCaml or SML. So if you take what you learn from Elm, you can actually apply it to a lot of other functional languages. And the ideas in Elm are definitely adaptable to React. We actually use a very similar pattern like this at Uber for some of our applications. Maybe soon we'll start using Elm, but still some questions to be answered there. And there are several other good tools that do very similar things to Elm, but I would say are probably not as easy to learn. So there's ReasonML from Facebook. This is very similar. And there's PureScript, which is like an even Haskellier Elm, which makes it maybe a little bit more intimidating.